Suppose a point moves along a circle of radius r and the ray from the center of the circle to the point traverses theta radians in time t. Let s equal r theta, and we will need this later, be the distance the point travels in time t. Then the speed of the object is given by these two formulas. First we have omega equals theta over t, which is the angular speed. And then we have v equals s over t, which is the linear speed. So we're going to find the linear and angular speed for the following question. A radial saw has a blade with a 6-inch radius. Suppose that the blade spins at 1000 RPM, 1000 revolutions per minute. Find the angular speed of the blade in radians per minute. So we're trying to find the angular speed, and the angular speed equation or formula is given by omega equals theta over t. So we need to know theta and t. Now it wants it in radians per minute, and lo and behold, we have 1000 revolutions per minute. So we already have these in the same units of measure, per minute. So all we really need to get is theta. Now theta is going to come from the 1000, because the blade spins, it goes in a complete revolution 1000 times in a minute. And theta needs to be in radians, which we know is 2 pi for a complete revolution. So if it goes around 1000 times in a minute, we can just do 1000 times 2 pi. And that will give us 2000 pi. And that's what theta is. And again, we need to find what the angular speed is, and since it's already in revolutions per minute and it wants radians per minute, omega is just 2000 pi radians a minute. That is the angular speed of the blade. Next, we are going to find the linear speed of the saw teeth, each little blade on the saw, in feet per second. So now we're doing feet per second. We got to be mindful of that. So the formula for linear speed is v equals s over t. And as I said earlier, we're going to need this later, s equals r theta. So we're also going to use that formula below. So s equals r theta. Now, to find the linear speed v, we need to know s and t. So, the only way to know s is to figure out r and theta. Now we know what theta is. We did it on the previous part. And previously we said theta was 2000 pi. Now, the radius, as it says here, is 6 inches. Simple enough. Problem is, they want it in feet. So what we got to do for the radius r is that it's 6 inches. We need to convert it to feet. So we can just take this and say that the radius is 6 over 12. Just divide the inches by 12 inches, and that's going to end up giving us a half foot. So now we know theta and we know r, so we can plug it in and get s. So s equals 1/2 times 2000 pi. Nice and easy. S equals 1000 pi. So now I know s, but to do the linear speed I also need to know t. And t is in seconds. So we know that before it was dealing with per minute. So t is equal to 1 minute, but we need to convert it to seconds. So 1 minute is just 60 seconds. Now we have everything we need. We have s, we have the converted t. So now v is equal to 1,000 pi, and that looks like a 6. Let me fix that. 1,000 pi over 60. And when we simplify that down, v is going to equal 50 pi over 3 feet per second. But if you want the actual approximation that's a little bit easier to see, this actually turns out to be 52.36 feet per second, rounded to 2 decimal places. So the approximate answer and the exact answer for this question.